So we're here at the American Association of Physics Teachers Conference, and we figured we'd take one of the office hours questions that was definitely a little bit tougher to approach and generated a lot of debate, and see what some of the best teachers in the United States and abroad had to say about this question. And it's a tough one. We're getting a lot of different opinions on it, so I hope you appreciate the views you'll see tonight. We have this online course that we're doing, and the students ask us questions for office hours every week. And this week's question got some debate going, so I'm trying to get people to sit down and talk about it for a minute. The question was, when a car accelerates, what does the work on the car?
That's a subtle one.
I have a different question.
Yeah, go sucker some people into answering this question.
Okay.
So if you're interested, you can have a seat and talk to the students a little bit about it. You can go through the normal thought process, just do it out loud.
Yeah. I don't think I can give the answer to that right away. I'm gonna have to think about that.
Okay.
When a car accelerates, what's doing the work? Well, first we should define our terms. A car can accelerate by 3 actions normally, either stepping on the gas pedal, stepping on the brake pedal, or turning the steering wheel. Each one of those will cause an acceleration. When I step on the gas pedal, if you're talking about positive acceleration and I accelerate in the forward direction, what's causing the force to accelerate the car has to be some external force. That would be the force of friction. So it's an interesting place where the friction between the tires and the car is causing the acceleration in the forward direction. But what's causing the work to be done on the car? We step on the gas pedal, we're using chemical energy from gasoline in the internal combustion engine, burning the gasoline, getting the engine to move, which we can then get to axles to move, which can get the wheels to move. So this is an interesting case where the force that is accelerating the car is actually the friction between the tires and the road, but the work that's being done on the car is from an internal source of energy, the gasoline in the combustion engine.
Cool. Thanks, man. I mean, this doesn't bother me that much. Maria will laugh at me. It's fine. I'm going to go with friction. Okay. I mean, I guess, but I still don't know if I like the question. Let me think about it. Yes, here it goes. Okay, we can think about energy. Change in energy equals work done by non-conservative forces.
Okay.
Right? So that's one very simple connection to make, is the work done by non-conservative forces in this situation is the friction applied to the car by the road. There's my answer.
Cool. Thank you.
No problem. No, let's come back to that. That's a good point. That's a very good point. Because if you take our course, just mechanics, then it's about the system, it's accelerating, and on that framework, I think it's better to say that friction force is causing it. Now, you go to the tire and you know these internal forces and things that we're trying to neglect because we're taking the car as a system. You have to look at it in a different lens.
My friend and colleague Colin asked me a question: when a car accelerates, what does the work on it? So the thing is, you need to distinguish between work done by a force and work as we understand it, in everyday terms. If the car is accelerating, then there is the force acting on it. The force acting on the car is the friction force. And if it's accelerating, it means that the friction force is doing the work. This seems counterintuitive because when we're thinking about work, we're thinking about the engine. But then you have to think about the engine as a system by itself.
I just want to say that I feel more confident in my answer now that Professor Safe has done it.
What about the engine makes it weird?
Well, because the engine is part of the system. It's part of the car. The only force that you see outside the system is the frictional force.
Okay.
You're thinking about the energy, like where does the energy come from? And it's a little bit weird that friction is what does the work.
Obviously, you can tell them because they need to hear alternative viewpoints on this. But no one said that yet.
Work is really a transfer of energy from one system to another. It doesn't really make sense to talk about something doing work on the car to accelerate it, because that would suggest that energy is coming from outside the car being transferred to the car. Instead, it's energy that's being transformed inside the car from one form to another.
Thanks. Tell me about your thought process here.
Well, I'm contemplating the friction.
Okay.
Because I want a picture. Where's my piece of paper so I can hold up my model, right? So if I think about the tire, the friction on the tire actually at the contact point points forward. So that's that's where the force is that actually is external to the car system that allows it to accelerate forward.
Okay.
So the tire is rotating this way, which means this point is actually moving this way, V. So F is forward. So I can't say anything until I figure it out.
Okay. Thanks for coming by anyway.
I may come back.
That'd be great.
Let me think on it.
Okay.
I'll be back.
Sure.
I'm going to take my little picture with me.
Awesome.
But nice car.
Thanks. This is my car. The car goes downhill. Car goes uphill. Good car. So when a car accelerates, what does the work on the car?
I would say nothing. I would say there's no work done on the car. I would say that there is a transformation of the energy. So the energy, which is the chemical energy of the fuel, is converted into the kinetic energy of the car. If you take into account the exhaust gases and some heat that goes out, some internal energy that goes out, if you take all this into account, of course, the energy should conserve.
Okay.
But I see that no work is done because the point of contact doesn't move really. So there is a force, a static friction force. I assume there's no skidding, of course.
Right.
But that point is not.
So you're saying that basically when the wheel comes down, it just touches and then picks up, and that makes a difference for the. Okay.
Is that all?
Okay. Thanks for helping out. Yeah, that was
Okay. Work is a force times a distance, and that force has to be in the same direction that the car is moving. So the car is moving forward, which means there has to be a force pointing forward. The only force that could possibly point forward on the car is friction. Now let's think about how possibly friction could, because it seems counterintuitive. Right? So let's consider a wheel. Here is a wheel. And we're going to let the wheel rotate in the direction of the arrow. Now let's focus at the point at the very bottom of the wheel. One point at the bottom of the wheel. What direction is that point moving? Backwards. So the velocity of the point at the bottom of the wheel, where the wheel makes contact with the road, is backwards. So the point at the bottom has a friction force, and that force points forward. So friction is the force that does work on the car that causes it to accelerate forward. Now, many people get stuck on, well, what does the engine do then? If I take a car, put it up on blocks, get the engine going, the drive wheels, usually the front wheels will spin, but since they're not in contact with the road, the car just sits there on the blocks with the front wheels spinning. Only when I take the car and lower it down and make contact between the wheels that are spinning and the ground does the car accelerate forward. So the purpose of the engine is to get the wheels spinning so that you get the friction, allowing the car to accelerate forward. The end.
Yeah, I see what you're saying. So if the car was not connected to the ground, how do they define work?
the integral of force over distance.
Force of war.
Is external, non-conservative
Okay,
forces.
so in that sense, then I should start from the beginning. The important point is that you have transform energy from the bonds, the energy gets transferred into kinetic energy of the car. I like the definition that captures the physical essence, namely the transfer from one form of energy to another.
Thank you.
Yeah, sure.
Say what you were thinking right there.
Internal combustion happens, so you have these little tiny explosions going on, and they push pistons and that turns the wheels. I feel like there's work happening there.
So far, you've connected the energy from the gasoline to the pistons to the drive shaft to the wheels.
Yes.
Can you go out farther to the car as a
Do
whole?
the wheels do anything on the road? Okay, so the wheels are in contact with the road. A point on the tire that's in contact with the road is going to be in contact with the road more than instantaneously.
Okay.
So it's going to come down into contact at some point with the road, and there's going to be at least some small distance where it is in contact with the road before the rotation picks it up off again.
Is that from dragging, or is that just from the fact that it's made out of rubber and it squishes some? Or?
Only in a completely ideal physics problem sense could you have, I think, only one point of contact. I think any real car is going to have, there's going to be some deformation of the tire, so there will be a little surface, at least, of contact. I think that's all I've got for now.
Okay. Thanks for coming over.
Yeah, sure. This is a really interesting...
What does the work on the car?
There is no work done on the car to the approximation that the wheels do not slip on the pavement. The work done is zero, because the force of the pavement on the bottom of the wheel acts through zero displacement, because the velocity of the bottom of the wheel, the non-slipping wheel, is at all times zero.
Okay, so you were talking about like when the tire comes down and just makes contact and lifts up again.
Yeah.
You're saying that makes a difference.
There's a section, full contact between the bottom, the flat, compressed bottom of the wheel and the pavement, and there's no place there in that contact area where there's any motion. So the work done is neglecting air resistance.
Right.
The work done in the car is zero.
Okay. So where does the energy come from that makes the car move fast then?
Have you noticed you have to buy gasoline? The energetics of the car is that you burn gasoline or you drain a battery or whatever, and that does two things. It increases the translation kinetic energy of the car, and this is one piece of the energy. It's not the only piece of the energy for the system of the car. Nevertheless, the motion of the center mass point, which is here, is entirely determined by the net force which is applied down here at a place where there's no displacement in the room.
Well, thank you for coming and talking about it.
You're welcome.
You want to be on camera for a minute? Send Karen Cummings over here. She's my old boss.
And what generates the work to accelerate the car?
Yeah.
Well, unlike sliding friction, which is always opposite the direction of the sliding motion, this friction, often called rolling friction, is directed in the direction of motion, which is also the direction of acceleration. So that's sort of unusual for friction.
Okay. Thanks for talking.
You're welcome.
Cece, you wanna be on camera?
My official training is still in chemistry. Work is force times distance, so I need a force in the direction that I'm moving in order for work to be done. Otherwise, there's no work done.
Okay.
Right? Car is accelerating. Right. So the wheels are pushing against the ground, which exerts a third law pair force back the other way. So the ground is the one doing the pushing forward. But if you didn't have friction,
Okay.
if you were doing this on like ice, then your car wouldn't accelerate because you wouldn't get a push.
Sam, you want to explain physics?
Thanks, Cece.
Okay, so you say work, and I think force applied over a distance. The thing contacting the car is the ground, because the wheels are in contact with the ground. And as it accelerates, it has static friction with the ground. I'm searching for something what I would consider a distance for the force to be applied over a distance. And then
Okay. So
it circles.
So which force are you trying to look at for application over a distance?
Well, so the first thing I went to look at is the tire in contact with the ground as being what's pushing the car forward. What's that interface is. I mean, there's the engine's on there, but it's
attached to the car internally.
In terms of systems, I'm happy to think of it as a block that's moving along the road and accelerating. So I guess the only real surface that I can consider as interacting with that system would be the road. Not so much because I feel like I've fully satisfied the distance aspect of work, but because thinking about my system, what else is interacting with it, that's through process of elimination.
Okay, thanks.
Yep.
You asked.
All right. We've had about 10 people over the course of about 2 hours. I think we're going to call it at this point. We're going to call it a night and head home. So I hope you appreciated hearing all this stuff about work. Thanks.